students, welcome back to our channel. Has it ever happened that you are on your way to school on a rainy day, skipping over puddles everywhere, when your eyes suddenly fall on a beautiful pattern on one of the puddles that resembles a rainbow? From your junior classes you have known that pattern is caused by oil spills from different vehicles. But have you ever wondered how exactly the physics behind this works? Our today's video is to answer the reason behind this in a very subtle manner, details of which will be taught in higher classes. Now my question is, can a glass slab bend different colored lights by different amounts? To answer this, let us first revise the laws of refraction once. We have two laws of refraction. First, the incident ray, the refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. Second, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media. This constant is called the refractive index of the second medium with respect to the first medium. This law is also known as Snell's Law of refraction. Let us understand each of these very carefully. We have our incident ray, our refracted ray, and our normal. All these intersect at a single point known as the point of incidence, and this point of incidence lies on the refracting surface. Again, all of these, that is, the incident ray, the refracted ray, the normal, and the point of incidence lie on the same plane as can be seen from the diagram shown. Now let us talk about Snell's law, the mathematical details of which require knowledge of trigonometry, and will be taught in higher classes. Snell's law works under number 1, the relative physical properties of the two media concerned, and number 2, the color of the incident ray. The physical quantity that takes into account all these is termed as the relative refractive index, or in most cases, simply refractive index. Apart from the refractive index, the angle of incidence, I, is also important. Refractive index of vacuum is conventionally taken as 1. Refractive index of air is often taken approximately as 1 for ease of calculations. The refractive index of any medium is measured against vacuum or air and is always greater than 1. A higher refractive index means light will bend more from its original path. A lower refractive index means light will bend less from its original path. For a pair of media with medium 1 as the incident medium and medium 2 as the refractive medium, the relative index is given by m equals to m2 divided by m1. If m is greater than 1, light bends towards the normal. And if m is lesser than 1, light bends away from the normal. A very important note is that the refractive index is always greater than or equal to 1. But the relative refractive index can be greater than 1 or lesser than 1 or equal to 1. Let us understand Snell's law from a few examples. Here we have two media. First, glass with a refractive index of 1.50 and, second, water with a refractive index of 1.33. We can clearly see from the diagrams how refraction works with a variation in relative refractive indices. Now coming to a particular pair of media, we see how Snell's law works for light rays of different colors. From experimental observations, we have calculated the values of refractive index for an airglass interface of different colored light rays, and it tends to follow this trend with red light having the lowest refractive index and violet light having the highest refractive index. Thus, more the refractive index, more is the bending of light ray, as can be clearly seen from the diagram shown. Thus, as we see in the case of refraction through a glass slab, violet ray bends more than red ray. But after coming out of the glass slab, both of them emerge out with the same angle of emergence I, but have different lateral shifts. So, coming back to our question, can a glass slab bend different colored lights by different amounts? The answer is yes, it does bend, but only inside the glass slab. And no, it does not bend after the rays come out of the glass slab. So students, I hope we have finally learned how bending of lights of different colors work and how such colorful patterns are made. Physics indeed is amazing, right? That brings us to the end of today's video. For more such concept videos on science and technology, visit our channel Experihub on YouTube and Instagram. Links will be given in the description. And we will see you guys in the next video. Till then, keep learning.